Hello everyone, I'm Blue. Today I'm going to talk something about the black hole. First, may I introduce what is black hole. Imagine this is the time and space. According to Einstein's general relativity, the mass can twist the time and space and then drag anything close to it towards it. And this is called gravity. Imagine when the mass gets bigger and bigger and finally they create something like a hole on the time and space, and anything that drags towards it will finally disappear from the time and space. And this is what we call the black hole. Of course, this is an interesting metaphor. Next, scientifically, we're going to talk some properties about the black hole. First, let me talk something about the originality of the black hole. When the fuel for the nuclear fusion runs out, the star prepares to die. Its core rapidly contracts, collapses, and explodes under its own gravity. Its size gets smaller and smaller, while its density gets bigger and bigger at the same time. At last, even the neurons are crushed by the extremely large gravity, and anything getting close to it gets sucked in. The black hole forms at this stage. The existence of black hole was first predicted with Einstein's general relativity equation shown on the left side of the slide. You may have a look. Next, we'll have some introductions of some basic properties of the black hole. First is the singularity and the Schwarzschild radius. Here is the formula of the Schwarzschild radius, and singularity is a point at the center of the black hole whose size is zero and density is infinite. The event horizon is a sphere bounded by the singularity and the Schwarzschild radius. What happened in the event horizon can never be known from the people outside the event horizon because the lights cannot escape. Next is the no-hair theorem. This theorem was proposed by Stephen Hawking. He said all the properties of the black hole can be described with three terms, that is mass, angular momentum, and electric charge. This is really surprising, because the black hole sounds very mysterious for us, but Hawking told us actually, it is very simple. It is so simple that we can only use three terms to describe all its properties. The next property is the Hawking radiation, which is also discovered by Stephen Hawking. Close to the black hole, the gravity is so big that the virtual particles in the vacuum was teared apart into two particles, with one particle and one antiparticle. With one falls into the black hole, the other escapes. Thus, when we conclude, the black hole actually radiates. Last, I'm going to talk about the picture of black hole that came out about 2 weeks ago. It is a black hole located in the AMA1D07 galaxy, which is 55 million light years from the Earth. We can tell from the image that it has great size, which equals to dozens times of the solar system. The solar system seems very small compared with the size of the black hole. We can see from here the Sun and the Pluto. Okay? The significance of this image is that this image strongly supported the general relativity because we predicted the existence of the black hole from the general relativity. I may say that Einstein is really a great person, and the general relativity is with great power. However, no theory is perfectly correct, and we need experiments and observations to modify the theory again and again. This may be tough, but we humans will never stop our exploration of the truth of the universe. Okay, that's it. Thank you for watching this video.